An ideal spring in a toaster has a spring constant of 400 newtons per meter and a length of 6 centimeters when the potential energy is equal to 0. The spring is compressed 5 centimeters when the toaster is fully loaded. Find the height that a 50-gram bagel must be dropped in order to load it into the toaster.
So first we have the bagel above the toaster. We're going to only show the spring inside the toaster for simplicity. The bagel is held above the toaster spring at a certain height h in the diagram. Then, the bagel is dropped and compresses the spring. The spring is compressed 5 centimeters from its initial position. We know that objects in the air have gravitational potential energy and that springs can store energy. Based on the information in the problem, we can determine that this problem will involve conservation of potential energy in some way.
Let's start with conservation of energy. Here we have initial potential energy plus initial kinetic energy is equal to final potential energy plus final kinetic energy. We know that both the initial and final kinetic energies are equal to 0 because it's dropped from rest and it comes to rest when it's in the loaded position. So our initial potential energy is gravitational potential energy, which is equal to mass times gravity times the height that it was dropped. Because our spring is an ideal spring, the final potential energy is equal to spring potential energy, which is equal to 1/2 times the spring constant times the displacement of the spring squared. Because we're converting gravitational potential energy to spring potential energy, we start at two different potential energies equal to each other and solve for h, the height that the bagel was initially dropped. After completing our calculations, we find that the height that the bagel was dropped is equal to 1.02 meters.